Now on this page, we'll focus on how do you know if you've made a type 1 error or a type 2 error, and what's the probability of making each error? If the significance level is 5%, in other words, alpha is 0.05, then 5% of the time we will reject the null hypothesis when it is true. Of course, we will not know if the null is true, but if it is, the natural variability that we expect in random samples will produce highly unlikely results 5% of the time. This makes sense because we assume the null hypothesis is true when we create the sampling distribution. We look at the variability in random samples selected from the population described by the null hypothesis. Similarly, if the significance level is 1%, then 1% of the time, sample results will be rare enough for us to reject the null hypothesis. In this case, if the null hypothesis is actually true, then by chance alone, 1% of the time, we will reject the true null hypothesis. The probability of a type 1 error is therefore 1%. So in general, the probability of a type 1 error is alpha. And then on the other hand, what is the probability that we will make a type 2 error? The probability of a type 1 error, if the null hypothesis is true, is equal to the significance level, alpha. The probability of a type 2 error is much more complicated to calculate and beyond the scope of this course. Maybe in more complicated stats courses, you might learn that. We can reduce the risk of a type 1 error by using a lower significance level. The best way to reduce the risk of a type 2 error is by increasing the sample size. In theory, we could also increase the significance level, but doing so would increase the likelihood of a type 1 error at the same time. We discuss these ideas further in a later module.